A star 25 times the mass of our sun ceased to exist. No explosion, no warning, no corpse. Think about what that means. When a bridge fails, there are fragments. When an engine seizes, there is wreckage. Physics demands evidence. Mass does not simply stop. NGC 6946. The fireworks galaxy. Named because 9 supernovae have detonated inside it within recorded history. Astronomers watched it the way surgeons watch a critical patient, closely, constantly. In 2009, a luminous red variable inside that galaxy brightened to roughly 1,000,000 times the sun's output. Routine enough. These stars flare. They settle. They follow known rules. By 2015, it was gone. The Large Binocular Telescope looked. Hubble looked. Nothing at visible wavelengths, so they pointed Spitzer's infrared array, specifically the IRAC 4.5 micron channel, at the exact coordinates. What came back was a faint thermal echo. Not a body, not a remnant. A heat signature so dim it suggested the star hadn't exploded outward. It had collapsed inward, silently, completely, swallowed by its own gravity before the shockwave could even form. Here's what I keep returning to. We build our entire understanding of stellar death on one assumption, that dying stars announce themselves. That mass this large cannot disappear quietly. If that assumption is wrong, how many others did we bury underneath it? If you've ever needed somewhere that follows the anomalies instead of the textbook, this channel exists for exactly that. Subscribe. We don't flinch. Because what Spitzer detected in that infrared channel in 2015 is not the strangest part of this story. Here is what Spitzer found. Not a supernova remnant. Not cooling ejecta. A faint infrared excess. The thermal afterglow of dust. Dust that was already there before the star vanished. The star didn't scatter material outward on its way out. It left the dust behind, like a body that evaporates inside its own clothes. The working model is a failed supernova. The core collapses, but the shockwave, the one that should tear the outer layers into that signature explosion, simply never forms. The envelope falls inward before it can escape. What remains is a black hole that announced itself to no one. The Large Binocular Telescope Transient Survey had been monitoring roughly 16,000 red supergiants across 27 galaxies for over a decade when this was confirmed. 16,000 stars. One disappeared this way, which sounds rare, until you do the math. Theoretical models predict that somewhere between 10 and 30% of all massive stellar deaths are failed supernovae. Silent collapses. If that range holds, we have been systematically undercounting black hole formation in every galaxy we've ever surveyed. Every rate. Every simulation. Every cosmological model built on supernova frequency is off. Not slightly off. Structurally off. And here is the detail that nobody talks about in the summary articles. HETS's WFC-3 camera returned to those coordinates and found no point source down to a limiting magnitude of 27 in the near-infrared. That is the faintest threshold Hubble can resolve at that distance. There is nothing there at all. A star that massive doesn't just go quiet. Something about the way it died we genuinely do not have a model for yet. Part 3 is where the numbers stop being academic. Let's talk about what a failed supernova actually does to a galaxy. Not philosophically, physically. When a massive star dies in a normal supernova, it seeds the surrounding interstellar medium with heavy elements: iron, nickel, the precursor materials for rocky planets, for chemistry complex enough to eventually become biology. The explosion is violent, but it is also generative. It is the mechanism by which the universe builds complexity. A silent collapse gives you none of that. The mass falls inward. The heavy elements follow. The black hole keeps them. Whatever was inside that star, whatever it spent millions of years forging in its core, is simply removed from circulation. Forever. Now scale that. If 10 to 30% of massive stellar deaths are silent, then a significant fraction of the universe's chemical output has been disappearing into black holes without us accounting for it. The enrichment models we use to explain why planets like Earth exist, why carbon exists in the concentrations it does, those models have a leak in them. JWST's NIRSpec instrument has begun surveying stellar populations in galaxies at redshifts above 6, the early universe. What it is finding, quietly, in datasets from the JADES survey, is a deficit, heavy element abundances in certain early stellar populations that do not match what our enrichment models predict should be there. Nobody is calling it a crisis yet. They are using words like tension, like unexpected scatter, the careful, hedged language of people who have found something they are not ready to name. N6946BH1 was one star. One data point. But data points have a way of becoming the first sentence of a much longer, much darker paragraph. Part 4 is that paragraph. Here is the part that kept me awake. We detect stars by their light. We confirm their deaths by the absence of that light plus the presence of something else. A remnant, a nebula, a pulse. The entire architecture of stellar astronomy is built on the assumption that massive objects leave evidence, that the universe is, at minimum, legible. N6946BH1 left a thermal whisper in one infrared band, and then nothing. If it had been located in a more distant galaxy, if Spitzer's resolution had been fractionally worse, we would have simply logged it as a variable star that faded, filed it, moved on. Which means the question is no longer how often this happens. The question is how long it has been happening without us noticing. LIGO has detected gravitational wave events consistent with black holes in mass ranges that standard stellar evolution cannot easily produce.
The so-called mass gap, black holes between roughly 50 and 130 solar masses where pair instability supernovae should theoretically prevent formation, keeps producing detections. JW190-521. A merger involving objects that should not exist by conventional collapse pathways. Failed supernovae from stars above certain mass thresholds may be filling that gap silently, one invisible collapse at a time. We built a census of the universe using explosions as our counting method.
We assumed that what dies loudly represents what dies. We were wrong about one star in a galaxy we were actively watching, with instruments pointed directly at it. I don't know how to overstate that. We were watching. And we almost missed it entirely. There are approximately 2 trillion galaxies in the observable universe. We have detailed monitoring programs covering a fraction of 1% of them. The fireworks galaxy earned its name from everything we saw burn inside it. We have no name yet for what we didn't see.